Hello everyone, welcome to PharmaGrid. So let's continue with the body cavity systems related calculation series. Question number 46. Calculate the amount of base required for the following formulation. Hydrocortisone 30 mg, displacement value 1.6, benzocaine 5%, displacement value 2, marsupial quantity sufficient, and we need to prepare 12 suppositories and assume calibration of mold is equal to 1 gram. So in this formulation, there are two active constituents or two active ingredients, that is hydrocortisone and benzocaine 5%, and we need to calculate the amount of the base required for this formulation. Okay, so here the answer is option A, that is 11.17 gram. Let's see how we will do this calculation. As I have already mentioned, this formulation consists of two active ingredients, that is hydrocortisone and benzocaine. So firstly, calculate the amount of base needed for 12 suppositories containing 30 mg hydrocortisone. So we know that the formula for calculating the weight of base equal to mold calibration minus drug dose in gram divided by displacement value, all multiplied by base density into number of suppositories. So here mold calibration is equal to 1 and the drug dose, here the drug dose of hydrocortisone is 30 milligram. We need to convert it into gram. So it will be 0.03 gram divided by displacement value of hydrocortisone. Displacement value of hydrocortisone is 1.6 into 1. 1 is the base density and 12 is the number of suppositories. So the answer will be 11.775 gram. So 11.775 gram is the amount of base needed for 12 suppositories containing 30 mg hydrocortisone. Hence, weight of the base plus weight of hydrocortisone in 12 suppositories is 11.775 gram. This 11.775 is the weight of the base plus 0.36 gram. 0.36 gram is the weight of hydrocortisone. How we got the weight of hydrocortisone? We know that the dose of hydrocortisone in gram is 0.03. Okay, so this is the weight in 1 suppositories. So for 12 suppositories, multiply this value by 12. That is 0.03 multiplied by 12. We will get 0.36 gram. Okay, so 0.36 gram is the weight of hydrocortisone. So 11.775 plus 0.36, we will get 12.135 gram. Okay, so next take the case of benzocaine. So secondly, determine the amount of benzocaine needed for 12 suppositories. So in the equation or in the question, they have given that benzocaine is present as 5%. Okay, so 5% means 5 gram is present in 100 gram. So let it be x gram present in 12.135 gram. Therefore, x is equal to, cross multiplying, we will get 5 into 12.135 divided by 100. That is equal to 0.606 gram. So the 0.606 gram is the amount of benzocaine needed for 12 suppositories, which is 5% of 12.135 gram. So finally, the amount of base actually needed is equal to 11.775 gram. So what is this 11.775? 11.775 is the amount of the base needed for 12 suppositories. Okay, so this is 11.775. Those 11.775 minus 0.606. 0.606 is the amount of benzocaine. Okay, so this amount of base minus amount of benzocaine, we will get the total or the actual amount of base needed. That is equal to 11.17 gram, which is the answer. Question number 47. Prepare 8 suppositories each containing 50 mg of the anti-nausea drug dimenhydrinate. How much macrogol base do you need? The data given is calibration of mold with fatty base equal to 0.9 gram. Displacement value of dimenhydrinate is equal to 1.3. Density of macrogol base equal to 1.2 gram per ml. So use the same equation, that is weight of base equal to mold calibration minus drug dose in gram divided by displacement value, all multiplied by base density into number of suppositories. Okay, so here the dose of the drug is given as 50 milligram. So 50 milligram should be converted to gram. So that will be 0.05 gram. So the amount of macrogol base required for 8 suppositories equal to, substitute all these values in the equation. So we will get the answer as 8.27 gram. So here the correct answer is option B, that is 8.27 gram is the amount of the base or the amount of macrogol base required to prepare 8 suppositories. Next question. Calculate the percentage error involved if displacement values were used in the calculation of the following formulation. Bismuth subnitrate 10% having displacement value 5. Formulate 10 into 1 gram suppositories in a fatty base. Assume calibration of malt is equal to 1 gram. So in this question, we need to calculate the percentage error. So how we will do this? Here, we will calculate the base required using the correct method and the displacement method, and thereafter we will find out the percentage error. Okay, so using the correct method, in the question they have given the strength of the drug is 10%. 10% means 10 gram is present in 100 gram. So let it be X gram in 10 gram. Okay, because we need to prepare 10 gram suppositories. So we need to find out the amount of bismuth subnitrate present in 10 gram. So let it be X gram. Therefore, X is equal to 10 into 10 divided by 100. That is equal to 1 gram of bismuth subnitrate. So this 1 gram of bismuth subnitrate is the amount of drug present in 10 gram of the suppository. So the amount of fatty base needed will be equal to 10 gram minus 1 gram. That is, the amount of fatty base needed is equal to total weight of the suppository, which is 10 gram, minus weight of the active ingredient or weight of the bismuth subnitrate, that is 1 gram. So amount of fatty base needed is equal to 9 gram. Okay, so 9 gram is the amount of the base needed using the correct method. Now using the displacement method. Displacement method, we use the same equation to calculate the weight of base. 1 is the mole calibration and 0.1 is the drug dose in gram. So how we got the 0.1? We know that the strength of the drug is given as 10%. Okay, so this 10 gram is present in 100 gram. So let it be X gram present in 1 gram. Okay, we are calculating the amount of drug present in 1 gram of the suppositories. Okay, so we will get it as 0.1 gram. 0.1 gram is the 10% of 1 gram. 10% of 1 gram suppository. So divided by 5. 5 is the displacement value multiplied by 1, which is the base density, and number of suppositories equal to 10. So that is equal to 9.8 gram. So 9.8 gram is the amount of base we calculated based on the displacement method. Now we will calculate the percentage error. Percentage error is equal to estimated value minus original value divided by original value, all multiplied by 100. Or we can say that percentage error is equal to higher value minus lower value divided by lower value into 100. That is 9.8 gram minus 9 gram divided by 9 into 100. That is equal to 8.9%. So here the correct answer is option A, that is 8.9% is the percentage error involved. Question number 49. Calculate the percentage error involved if displacement values were used in the calculation of the following formulation. Iodoform 10%, displacement value 4. Formulate 10 into 1 gram suppositories in a fatty base. Assume calibration of malt is equal to 1 gram. So here also we need to calculate the percentage error. So first we will calculate the amount of base required using the correct method. So 10% of 10 gram suppositories. That is, we need to prepare 10 gram suppositories, and iodoform, which is the active drug, its strength is 10%. Okay, so 10% means 10 gram is present in 100 gram. So let it be X gram present in 10 gram. So let it be X gram. X gram is the amount of drug present in 10 gram of suppository. Therefore, X is equal to 10 into 10 divided by 100. That is equal to 1 gram of iodoform. So how we will calculate the amount of fatty base needed? Amount of base will be equal to total weight of the suppository, which is 10 gram minus 1 gram. 1 gram is the amount or the weight of iodoform. So 10 minus 1 is equal to 9 gram. So 9 gram is the amount of fatty base needed, which we have calculated using the correct method. Next, using the displacement method. So 1 is the mole calibration, then 0.1. As in the previous question, how we will calculate the 0.1? 0.1 is the drug dose in gram. Okay, we need to calculate the drug dose in 1 gram of the suppository. 1 gram of the suppository. So the 0.1 gram is equal to 10% of 1 gram drug, divided by 4, which is the displacement value, multiplied by 1, which is the base density, and number of suppositories equal to 10. So answer is 9.75 gram. So this 9.75 gram is the amount of fatty base we have calculated using the displacement method. Now percentage error is equal to higher value minus lower value divided by lower value multiplied by 100. That is, higher value is 9.75 minus 9 divided by 9 multiplied by 100, that is equal to 8.3%. Okay, so here the correct answer is option C, that is 8.3%, which is the percentage error involved. Question number 50. How much PEG base is required to prepare 10 into 1 gram of the following formula? Paracetamol 250 mg, displacement value 1.5, PEG base quantity sufficient. Assume calibration of malt is equal to 0.95 gram. Relative density of PEG base to hard fat is equal to 1.2 gram per ml. So here we use the same method or the same formula to calculate the amount of base, that is the displacement value method. So here the calibration of mold with the fatty base equal to 0.95 gram and the dose of the drug is equal to 250 milligram. Okay, 250 milligram converted to gram, we will get 0.25 gram. Then displacement value of the drug is equal to 1.5. Density of PEG base equal to 1.2 gram per ml. Amount of PEG base required for 10 suppositories will be equal to 0.95 minus 0.25 divided by 1.5, all multiplied by 1.2, which is the base density, into 10, which is the number of suppositories, that is equal to 9.4 gram. So here the correct answer is option B, that is 9.4 gram. Okay, so with this question we have completed this body cavity systems related calculations. Thank you. Have a great day.